Does that make sense, what we just did there? In order,
I don't understand the second part.
You don't?
No.
Okay. What does it mean if antiderivative from a to b of f of x is equal to 0? What does that mean?
It means that you have both negative and positive that cancel out.
Correct. All right, so we had area that canceled. That means we had to have some positive and we had to have some negative.
Which is why A being all negative, B being all positive, I mean. E
Those
being
two
all
are
negative.
out, right. So A's answer would, again, because it is strictly increasing, it doesn't actually turn around and do something weird. That's what the F prime positive means. So A is out because that answer would have been totally negative. E is out because that answer would have been totally positive. C and D were out because they weren't increasing, which by default leaves B. You have some negative and some positive.
That second part, messing up.
87, the graph of f double prime. Ooh, f double prime, the second derivative is shown. What are all intervals on which the graph of the function f is concave down? Really?
This is 27.
This is
Yeah,
87.
I got it, okay. Yeah,
Uh,
I was going to get scared myself.
how do we find where a graph is concave down? What do we do?
We take two derivatives.
Good.
And then we say equals 0.
Find
and then-
possible points of inflection.
And see where the graph is negative.
Good, and then check the intervals in between. Here, this is like doing the chart where we check the intervals. They've just gone ahead and shown us the chart as a graph. So,
Nice.
where is my f double prime negative?
From -2 to -1 and from 1 to 3.
There it is, -2 to -1, from 1 to 3, which is E. Notice how little, if you go back and not look at, but remember the board full of work we did yesterday, and look at the board full of work that we're doing today, that the calculator part of this is not quite as intense, do I?
Why is it not also equals to -2? I don't. It's because
Say it
it's
again.
ending at, I thought if it ends, the graph ends there, it should be equal to.
Correct, but when you take a derivative, it washes out the endpoints because I don't really know what's happening on the other side. Good question. All right, 88. A person who's, you know what, I don't even have to look, I'm not even gonna read it. That looks like related rates.
It is.
Yeah.
Dang.
A person whose height is 6 feet is walking away from the base of a street light along a straight path at a rate of, wait for it, 4 feet per second. If the height of the street light is 15 feet, what is the rate at which the person's shadow is lengthening? We've actually done this problem in class.
I just don't know where like I found all the things I made, drew a picture, and I just couldn't find.
Equations?
It wasn't an equation, I just thought I needed something, like another number, and I couldn't find it.
Do what we can here. This is 88, is that right? So you have, all right, street light, guy,
Dang, why did Mark C move on? I don't think it worked this entire time.
no, okay. Give me some relevant information.
Mark B move on should have been like from this year. But,
Let's see. He is 6 feet, lamp is 15 feet, right? He is 6, he is 15. I can lock those in because they don't change.
Mhm.
Okay, now, I gotta be in related rates mode. Got it. What else did they tell me?
They tell you
Feet
that
per second?
He is walking away from the street light at a rate of 4 feet per second, which is this.
Yeah, so we can mark that as just X like that.
Alright, call that X, so dx dt is positive 4, because he's moving positive feet per second.
And then, that's,
And they want to know what's happening to the shadow.
which is what I,
What do you want to call the shadow?
let's call it S.
S, right? Not to be confused with 5, but there's S.
I think I
So
changed
they want to know ds dt.
it. Yeah.
Sweet, so all I need to do now is set up an equation of some kind, and take a derivative, and Bob's your uncle. This one's a proportion problem. So I would say, height of man is to height of lamp as length of shadow is to the bottom of this, which would be s plus x. Is there any part of that that does not make sense? We're doing similar triangles, we're doing this little triangle right here and then the whole triangle, so we did height to height and base to base. A lot of people incorrectly put the x as the base of this big one here. Now you can take a derivative, but I would suggest you do this first. If you cross multiply, you get 6s plus 6x equals 15s. If you subtract, you will get 6x equals 9s. You could even reduce that and get 2x is equal to 3s. And now, ladies and gentlemen, take a derivative. 2 dx dt is equal to 3 ds dt. We know dx, that's 4. So this is going to be 8 equals 3 ds. So ds dt is equal to 8/3. Which is B.
For some reason, I thought I need to know S or X or one of them.
Well, you would have if our derivative had left them behind. But when we took a derivative, all we had were dx's and ds's, so
I was just
we're done on that one.
thinking ahead, way too far ahead for something I didn't need.
You were looking for problems that didn't exist, yeah. Well, and I will say this, if you had done quotient rule on this, you would have had some s's and x left behind. Yes, you would have. But they would have washed each other out after the derivative. If you left it like this, quotient rule would have given you some ds's and dx's. This is by far the easier way to work that problem. All right, anybody get that one right? I think Jerry did, but I think you guessed. Oh, no, I did, yeah. I remember that one. I remember going, wow, good job, man.
That's the problem, you can't tell if we're guessing or not on these.
Yeah, they don't care. You could have a page full of gorgeous work. You could even write the right answer on your scratch work and then circle the wrong one. They're like, wrong. Too bad. 89, excuse me, a particle moves along a line so that its acceleration is given by that. If the particle's velocity at 0 is 5, what is the velocity of the particle at 3?
Oh yeah, I got this was fun.
This is pretty straightforward. We've done it way too many times. Okay, how do I get from acceleration to velocity? Acceleration to velocity, antiderivative, okay? Antiderivative of whatever that thing is, t plus 3 over root of t cubed plus 1. All right, so I know I got to do that. But they want to know what the velocity is at 3. Couple of ways to do this. Number one, do it like this, get a plus c, okay? And then use that initial condition that the velocity is 5 at 0 to help you find the c, and then plug in 3. That's option 1. Option 2 is to do this, which I think is a little bit more, it's less intense. Go ahead and do this from 0 to 3, and do the antiderivative from 0 to 3. Now what that's going to give you is the change in the velocity. Then, tack on an extra 5 because that's where you started. Okay? So 5 plus whatever that mess is right there, type that into my calculator and I will get my answer. A lot of people forget, and I'm betting that the right answer, if you did this, I bet this answer is on there and then 5 units away. So let me see, is there any one that is 5 units
Yeah.
away?
There is not one that's.
D to E is 5 units away.
Oh yeah.
B to C
B to C
is
is-
5 units away. So that right there is cluing me in, and that 5 is something that a lot of people forget to do. Let's see.
Even when guessing wrong.
Math 9, going from 0 to 3 of, let's do x plus 3 divided by the square root of x cubed plus 1 into x, and I get 6.710. So the wrong people would have put D instead of adding the extra 5 onto it to get E. Okay, so So without the 5, you would have gotten a D. If you knew what you were doing with the extra 5 to start with, you would have gotten the right answer. Number 9D, let,
D.
huh?
I got D.
An extra 5 there. Where are we, 90, let f be a function given by the integral from 6 to 12 of f of 2x. That's equal to 10. Which of the following must be true? All right, so now they're asking me something about regular old f of t.
I didn't understand this one.
Yeah, you did.
I did.
Yep.
Okay, I did.
Watch this. This, by the way, is a U-sub problem.
That's a sneaky use of right there.
All right, what did they put, 12 to 24?
12,
The original was 6 to 12.
12 and,
Okay. 6 to 12 of f of 2x.
oh, you use
DX.
which gives you U.
Okay, I'm gonna, because of the way the answers are written, I'm gonna do a t sub,
Yeah.
because all our answers are t. So I'm gonna let t be 2x.
Take it.
That means dt is going to be 2 dx. I don't have a 2 in the problem, so I'll bring it over here. 1/2 dt is equal to dx, all right? So I'm gonna rewrite this as 1/2 f of t dt.
Also, they,
And then change my intervals. If
Yeah.
x is 6, then t is 12. And if f is 12, then we get 24. Does any answer look like that?
if you equal to, it's the, there's 2 of them.
Oh, this was equal to 10?
Yeah.
All right.
So then that would be,
Well, that should still be equal to 10.
yeah.
All right, so it's still equal to 10. Did they do something with the 1/2?
Yeah, they
One half
brought the
went
one
over
half
the other
over.
side.
There it is.
20.
So 12 to 24 of f of t dt is equal to 20.
I'm pretty, yeah, they just, okay.
That one was a fancy, fancy way of doing a U-sub problem.
That's a sneaky way of doing it, so.
That's actually pretty straightforward.
Well, I mean, like, you wouldn't think of that.
I will.
You can do this all the time.
Wait. No, I haven't been teaching longer than you've been alive. This is year number 15 for me, so I'm getting close. I can almost say that. I've been teaching longer than you've been alive.
You can't say that to us ever.
No.
I'm sorry, you can't.
Yes, I'll never be able to say that to us.
To you, for 3 years, I will be able to.
In 3 years, what if something happens?
Or 5 years if it's a super, super senior, you never know.
God. We have we have a 21-year-old in last semester in my class. We never caught up at whose name it was, who he was.
All right, everybody see how that U-sub, this is a fancy way of doing by the way, Edward, you asked about U-sub. There's your U-sub problem.
Yeah.
Probably not the most straightforward way to ask the question, but there it is. 91, let f be a polynomial function with the values of f prime shown. Check.
Did you tell him what the other one was?
Do it.
Did you tell him what a Hongkong was?
Mongoloid, we'll get to Mongoloid in a second. Select the values of x given in the table above. Which of the following must be true between -2 and 6? Okay, this is f prime.
This one should be.
Did they say anything about it being continuous?
They did not.
Yes, they did.
Where?
You see the word polynomial? That implies continuous and differentiable. Ah ha ha ha. Okay. So I'm also, okay, if it's a polynomial, that means intermediate value theorem is going to apply and mean value theorem is going to apply. Which of the following must be true? The graph of f is concave up. Okay, think about this. F concave up. F concave up. F concave up means the second derivative was positive, which meant the first derivative was increasing.
It was at some
Okay,
point, not all.
but not all of them. There's that dip in the beginning, so we are not necessarily concave up all the time. The graph of f has at least 2 points of inflection.
Yes, somewhere.
I'm actually going to give that a yes.
That's what I said. Oh yeah,
That would be correct, I believe.
yeah.
Can you tell why?
Because Cause it goes from 3 to 1, so that means it's going down, and then it goes back up.
So somewhere in
It
that
goes
3 to
down,
4, yeah,
and
in
then it comes
that
back down at 7.
4 to 7 to 5, so somewhere, there were two spots that we know of, that we can confirm, that we changed direction,
Yeah.
which meant the second derivative would have been equal to 0 at some point in there, all right? F is increasing, no,
No.
well, it's clearly not. F has no critical points. It could have hit 0 somewhere in between there.
Yeah.
Just because you only see positive values, by the way, doesn't mean there weren't some negatives squeezed in the middle, you know, like at
Okay.
1 or 1.5, yeah. F has at least 2 relative extreme, I got no idea. It could have none. By the way, F prime always being positive just means it's always heading,
Up.
well,
Well, I mean,
not always, but
No.
this one could imply that it is always heading upwards, which means I don't have to have 2 relative extrema. I can just be heading up the whole time. Beautiful, so the right answer for that one is B. I'm always amazed, I had 91 up there. I'm always amazed on this half of the test on how little you actually have to write down. This part of it, the calculator is way more thinking and interpreting.
which is.
Do you really understand your theorems and your,
Because
what's
they-
really going
That's why
on?
they put the calculator, not, they don't put the writing stuff.
Right, because if they don't want you to use a calculator, they've asked you a question that the calculator doesn't do you any good. So. Let R be, oh, I see
I
decimals.
hate when they do that.
Calculator.
I actually really hate that.
Let R be the region in the first area.
Finish strong on this one.
No, it's volume. Let R be the region in the first quadrant, bounded below by the graph of y equals x squared, and above by the graph of square root of x. Alright.
That good old,
You could have graphed it, by the way, but x squared looks like this, and square root of x looks like
I
this.
have to graft it.
So they're gonna meet at 1, 1, and at 0, 0, so there's my interval, or you could have graphed it and found that if you were a mongoloid.
You know what? Some people don't know exactly.
R is the base of the solid whose cross sections perpendicular to the x-axis are squares. What? We have literally done this problem in class. We have done this exact same problem. You have squares. There you go. All right, I need the area of a square,
Side squared.
side square. I need the length of a side.
Why?
Length of a side is gonna be top minus bottom, which in this case is going to be square root of x minus x squared, squared. All I need to do now, take an antiderivative of this over the correct interval, which if you graphed it or if you knew what it was from 0 to 1. So type all that mess into your calculator and it will give you an answer of something. 0.129.
See.
I think the right answer was A on this one, if I remember correctly.
Yes, it was.
So type that in your calculator, make sure you know what you're doing. Don't forget your square. Don't get this confused with washer, where you're squaring each one individually, which this is not. Ladies and gentlemen, calculator. 17 questions in 50 minutes. That is roughly 3 minutes and some change, about 3 minutes per problem. And notice how many of them really didn't even require you to write anything down. It's a lot of thinking, a lot of interpreting. Do you know what you're doing here? Okay. I need to take a breather. Potty break. Yeah. All right, let's rock and roll, people. No, she's still alive.
Making sure you're alive and not dead.
Then we get to free response, and I have to say, I was a little, I didn't expect the scores to be stellar, but I did expect y'all to do better than this, yeah.
What I get?
By the way, Green Sea has finished their version. They did the same test. They took it yesterday and today. And their scores were comparable to yours. Everybody felt solidly in that one range.
Dang.
I think there was like a 26, a 28, a 31, something like that. So they were at least high ones. They were 1 pluses. Yay.
Yeah.
You get there, yeah. They were close to that passing. I do have one kid that still needs to finish it. Theirs were a lot more consistent. Y'all's kind of bounced around a bit. Their free responses, however, overall were better than yours. Y'all were doing single digit stuff, a lot of it, they were, average for them was about 11 or 12 points, and for y'all it was a little bit lower than that, about 6 to 8 points on these. Okay, let's see. Number 1. Let's slow it down. We have 15 minutes per problem. It shouldn't take that long, but let's see what we can do. These are all calculator. All right, and I tried to be super wordy. When I graded these, I tried to give you lots and lots of like, here's what you're doing wrong, or fix this. So please, even though you don't get to keep these, look at what I've written. If you want to see it or use it anytime in class, you're more than welcome to, but these can't leave the classroom. These are pretty protected tests. The temperature of water in a tub at time t is modeled by strictly increasing twice differentiable function w. Most kids just skim over that without realizing the importance of strictly increasing twice differentiable.
Means you can take 2 derivatives.
It means you can take 2 derivatives with no bad spots, and that these values should always, and they are always increasing. That just means you won't see any dips down that are missing. Where W of t is measured in degrees Fahrenheit and t is measured in minutes. Anytime they make a big deal about units, you should make a big deal about units. At time t equals 0, the temperature of the water is 55 degrees Fahrenheit. The water is heated for 30 minutes. 30 minutes, the chart only goes up to 20. Beginning at time t equals 0, values of W of t at selected times for the first 20 minutes are given in the table. Check. I will also say, I don't know if this makes it easier for you all or not, but this is the way the answer key looks. So your A goes in the box, B goes in the box, C goes in the box, and D goes in the box. I think it helps you kind of organize your data a little bit more when you see it that way. Just, even though I didn't do that, it's too many copies, be ready for that on the AP. Use the data in the table to estimate W prime of 12. Estimate W prime of 12. Show the computation that leads to your answer, and using correct units, interpret the meaning of your answer in the context of this problem. Okay, part 1. What is W prime of 12? How are we going to find it? Sorry? I heard 2 people talking, I apologize.
I just said W prime 12.
Oh, what were you saying?
No, just the W15 is.
Good. Use the 2 sandwich points, the 9 and the 15. This is an algebra 1 question. Okay. They wanted us to find slope, which is W prime, using algebra 1 skills because we don't have everything in the middle. So W prime of 12 is going to be roughly equal to W of 15 minus W of 9 over 15 minus 9. That's straight up y2 minus y1.
Remember these for my quest?
You should. This is why I keep hammering them into you on the quest, because this is exactly like you've seen a dozen times. All right, so for us, that is going to be W of 15 was 67.9. W of 9 was 61.8. And 15 minus 9. Okay, so that gives us, what is that, 6.1? 6.1 over 6. That's an acceptable answer if you really want to leave it that way. I think the decimal is like 1.016 or 0.17, something like that. I think.
Actually, how to interpret it.
Show the combination that you answer. Okay, there. We found it. Here's the interpretation, or the work leading to it. Y'all really should get in the habit of being me. Write it exactly the way I do. I've told you what I'm doing. Here's my setup, here's the scratch word, here's my answer. Make it look good, y'all. Okay, what does this mean? First off, what does W prime of 12 mean?
W prime of, that's the slope of 12.
The slope at 12. This is our estimate for the slope at 12. Okay. What is a slope? Derivative. How much it's changing, rate of change. So that's how I would interpret this. The water temperature is, now, it's positive, so I'm not gonna say changing, I'm gonna say increasing at a rate of
1.017,
units,
degrees Fahrenheit per minute.
degrees Fahrenheit
Yeah.
per minute at T equals 12 a minute. Notice all the units in there. Here's the answer, and then all the units are wrapped around it. Was it Fahrenheit? Yeah, whatever Fahrenheit, that's Celsius, it's really hot.
That is very high.
Yeah. Cool. Water temp is increasing, because it's positive.
Actually, it's, both of those are extremely, it's not raising that high.
Well, 71 degrees Fahrenheit is tepid.
Yeah. Not like boiling.
B, do we have enough room for B? Use the data in the table to evaluate the oh yeah. You know, it's funny, y'all do great on the quest. I don't know, I don't know whether y'all just have extra time on the quest so you feel less stressed about it, or whether you go look up a video that's like, oh, yeah, that's how they do it, I'll do it this way. Either or, y'all should be really good at these by now. They want me to find the antiderivative from
I think it's a time strength.
0 to 20.
If you don't know it, move quick, don't think about it, just keep moving.
Okay, go.
Oh.
This is a no-brainer, by the way.
No-brainer. Really who it's asking to do.
Holy crap. Okay,
It's
I
W.
would-
what is the antiderivative of W prime?
It's
W.
WT evaluated from
So
0
it's
to
just
20.
71 minus,
So W of T, that's the antiderivative evaluated from 0 to 20, which is W of 20 minus W of 0.
I'm so upset.
W of 20 is 71 degrees. And W of 0 is 55,
That's good.
for a grand total of positive 16.
That's really good.
I think my
I got
phone was just
that.
like an overlay.
That's what I'm pretty sure. It was just the time string of, it looks weird.
First question, you weren't pressed for time yet.
that's great.
Well, we wasn't pressure time, but we had a time limit set on our heads, and we had to go through 6 of them.
So now I will stress to you, I will be the grumpy teacher from here on out. When I give you the quests, don't wait till Thursday night. Actually, that's perfectly fine if you want to do that, just give yourself exactly an hour and a half to take it. I would suggest when you do your quest, you set aside 15 minutes per problem. If you can't do it all at once, just do 15 minutes and then stop. Just stop. Maybe take a picture, maybe do and just keep track. This is what I could do in 15 minutes. You still have more time, go back and answer everything else, but just see where you fit. And the more you can force yourself to use 15 minutes at a time, actually 13, so that you always feel like you're safe if you practice with 13 minutes. Try that when you do any quests from here on out, which are still due Friday, by the way.
Yeah.
Remind me, because I need to give you back last week's quest too. Okay, so there is, evaluate that. Using correct units, interpret the meaning of that in the context of this problem. All right, what does this mean? First off, the number itself is important, the sign is important, the setup of the problem is important. What does that 16 represent?
It represents the,
Average?
No.
No.
Okay, why do we take an antiderivative?
to get area.
Area is one reason.
What's the other reason?
Think particle motion. When I take an
To find where
antiderivative,
the where it-
total distance, this is kind of a total distance question. That is the derivative, which is like a velocity for us. We took the antiderivative of the velocity, so we basically found total distance, but in this case, it's not distance, it's total
Change,
The increase.
in
temperature.
temperature, total temperature. So, the temperature increased
16 degrees Celsius
16 degrees Fahrenheit.
over 20.
from time t equals 0 to t equals 20 minutes. Units, I've mentioned the word increasing to show that I know the answer positive means this. Fahrenheit, minutes, the number itself. Right? See,
Oh, this one.
be angry at yourselves, or be disappointed, or be whatever you need to be, but learn from this. Whenever you see this on a quest, and you see it on every quest,
C.
know how to set the problem up, know how to interpret. Would y'all please quit losing points for show units, or explain the meaning of this? We've done those enough by now. C, for 0 to 20, the average temperature in the tub is 1/20. Good, that's the formula for average value, got it. Use a left Riemann sum with 4 subintervals indicated by the data to approximate that. Sweet, got it. All right, 1/20th antiderivative from 0 to 20 of W of t dt. Now we're going to find the antiderivative of that.
Okay.
Okay, now I clearly don't know what W is, but they told me to use a left 4.
Yes.
Left 4, sweet, okay. So the 1/20 is just going to tag along for a second.
I
Okay.
understand what you said 4.
Huh?
I understand what you said, you use 4.
Yes, because that's how many spacers we have in between there. Okay, number 1 is going to go from 0 to 4, so that will be a distance of 4. Okay, and the left side of that is the 55. Number 2 goes from 4 to 9, which is 5. And the left side of that is 57.1. Number 3 goes from 9 to 15, which is 6. No, 6. And the left side is 61.8. And then number 4 goes from 15 to 20, which is 5.
67.9.
67.9. Okay. By the way, this, whether you did the work or not, but writing this stuff down and say, here's where all the numbers go, that's your point. That's your Riemann sum point. Don't screw that up. This is our average value part of it. So now all I need to do is just crank through the numbers and get an answer. It is calculator, so I would use my calculator for this one. I'm not sure what it is.
60.79.
How much is it?
60.79.
The whole thing is 60.79?
Yep.
All right. Was there a third decimal there?
No. I don't want to round it down there. It's 1,215 divided by 20. 1,215.3 divided by 20.
60.79, right? Alright, so 60.79. How about units? Cover my butt on this one.
You didn't ask.
I didn't ask, but what would the units be?
Average temperatures of degrees Fahrenheit.
Degrees Fahrenheit. Good.